I'd like to explain how to solve systems of inequalities. We'll solve by graphing. You start by solving an inequality for y. Your inequality may already be written as y greater than or less than. We need to make sure that you have slope-intercept form. So it's very similar to if you have an equation, the difference is you won't have an equal sign. You'll have greater than or less than, or greater and equal or less than equal than mx plus b. You start graphing at the y-intercept. So we'll plot the y-intercept. So crazy looking. Except there, it's better. There'll be a point at 0, b, where your graph crosses the y-axis. From there, you can count slope to plot the next point. Slope is rise over run. So you'll have on the generally a fraction, if you have a whole number, you can write it over 1 so that it's a fraction. The top number will be boxes up, which is positive, or down, which is negative. The bottom number will be how many to count right, which is positive, or left, which is negative. So once you have your 2 points plotted, you can draw in a line. And depending on your inequality, this may be solid if it includes an equal, or it may be dashed if it is just greater than or less than and not equal. For an inequality, your solutions will be maybe the line, maybe not including the line, depending on if we're solid or dashed, and then everything that's above that line or below that line. So I'd like for you to draw arrows. Starting on that line towards the solution. And that the solution is for that one inequality. Let's scoot this over a little bit so it's easier to read. There, that's better. Okay, so then you repeat these 5 steps until all of your inequalities are graphed. We'll put for all inequalities. There. Your solution will be where the arrows point, where all of the arrows point. the area of the graph that's true for every inequality. So before you go shading everything in, let's use a test point. Where you believe the solutions are. And that's just to double check and make sure that before you shade, that you're shading the right area. And then you shade that solution. If from your test point, that point in the space is not true for any of the inequalities, double check your inequalities and then pick a different point in a different space if it doesn't work out for that area. When you choose a test point, don't pick a point on the line. Pick a test point in the space. When you have inequalities, we'll shade above or draw arrows up. When you have greater than or equal, and we'll indicate that the solutions are below when you have less than or less than and equal. You will perhaps have inequalities that are x x inequalities instead of slope-intercept or y. I'm having a struggle fitting this in here. Sorry. X inequalities cross the x-axis. So you'll have vertical lines that cross the x-axis. Y inequalities cross the y-axis. So if you have x inequalities, then you'll have a vertical line. So greater than is to the right. And less than would be to the left, because smaller x's are to the left and bigger x's are to the right. We'll draw a solid line when you have less than an equal or greater than an equal. It's because of the equal. And we'll use dashed lines when you have greater than or less than with no equal. You need to make sure that you remember any point on a dashed line are not solutions. They're not included. It's like an open circle. I say that because we'll also describe domain and range for these. There's one thing to remember about rearranging inequalities. We are graphing linear inequalities, but anytime you solve for y with an inequality, please remember that if you multiply or divide by a negative number, your symbol flips backwards. So make yourself a note. This is a two-line system, but I'm going to add a third inequality, and that will be an x inequality. We'll graph x is greater than or equal to -6. So here I have inequality 1, inequality 2. Both of these need to be written in slope-intercept form. I have space here to do that. We'll start with 3x minus 4y is less than 4. To make this in slope-intercept form, I need to move this 3x to the right side. When I subtract on the left, I have -4y is less than -3x plus 4. And then I'm still solving for y. I divide by -4. Make sure you divide each term. And since I just divided by negative, I flip this inequality symbol. So after I've divided, my inequality changes to greater than. So I have y is greater than 3/4. Negative divided by negative is positive, x, and then -1. When I graph this, I will have a dashed line with a positive slope, and my solutions will be above this line. We can go ahead and draw that one in. This will cross my graph where y is -1 and I have a slope of 3/4. So I count up 3 and write 4. And I draw in my dashed line. I'm going to give myself a little, few more guidelines since I don't have a ruler on here. There. So I draw in my dashed line. And as I said, this is the graph for inequality 1. My solutions are everything above this line. And I'll wait to shade until I know where what space is working for all the inequalities. I also need to rewrite the second inequality. So I subtract x. And I have 2y is less than or equal to -x plus 8. I'll divide by 2. Since I divide by +2, I keep the same symbol. So when I have it solved for y, I will still have less than an equal. This will be a solid line because I have less than equal with a negative slope. And my solutions will be less than, that's under this line. We can go ahead and graph that second inequality that crosses the y-axis at 4 and has a slope of -1/2. So I'm just making myself some extra lines on here. This will be, or extra points. This will be a solid line.
On the domain and range.
And the solutions are everything below this. Okay, here, let me get to a stopping point and I will help with domain and range.
Mhm.
The last inequality to graph is this third one. X is greater than or equal to -6. For this graph, I'll have a vertical line that crosses the x-axis at x is -6. I'll have a solid line because I have greater than and equal, and solutions that are greater are to the right. That graph will look like this. Oh, it's right on the arrow, I just drew. Everything to the right of this line satisfies this inequality. So my solution then should be where all of the arrows point. That's this triangle here. I'm going to choose a test point though and make sure before I shade it all in. So I'll test 0, 0. I substitute into each original inequality. I'll put 0, 0 for X and Y. And I'm trying to verify that this point does satisfy each inequality before I shade it in. If I get false, that it doesn't satisfy an inequality, then I choose a point in a different section, any of the other sections that are divided off. So, because if it tests positive in here, then every point in this section will work. If it tests false, then no point in here will work. I choose a different space. Make sure you don't choose a test point that's on a line, especially not on a dashed line. When I substitute, I'm going to use the original inequality. So this first one, I'll test 3x minus 4y is less than 4. When I substitute, I'll have 3 times 0 minus 4 times 0 is less than 4. And I'm checking this to make sure that it's true. 0 is less than 4. So that works out for that inequality. For the second inequality, I have x plus 2y is less than or equal to 8. So I need to make sure that 0 plus 2 times 0 is less than or equal to 8. Well, 0 is less than 8. So that works out. My third inequality is x greater than or equal to -6. So I'll substitute 0 for x, and I'm verifying that 0 is greater than or equal to -6. And it is. So this is my solution area. Every point above this dashed line and to the right of this solid line and below this solid line will work for my system of inequalities. So we can show with a graph where the solutions are for a system. We can also describe the solutions using domain and range for this shaded area. The domain for this area is describing x left to right. The smallest x is here at -6. So the set of all x's such that x is between -6 and 4. Because I have an intersection of a solid and a dashed line to the lower left, I can only use a less than. Any point on a dashed line is not a solution. Also, on the right boundary, I have a solid and a dashed line. And so that is also just less than, not equal. When I write this in interval notation, I'll write -6 with parentheses and 4 also with parentheses. The range for the solid or the shaded area is the set of all y's such that y is between the lowest is -6 and the highest is 7. At -6, I have a solid line and a dashed line, so I'll leave it less than. And at 7, I have 2 solid lines. So here, 7 is a solution for my system, your range. In set notation, I would write -6, 7. -6 is open because of the dashed boundary, and the 7 is closed because of the 2 solid line intersection.
Hold on.